the Sustainability Management Master's Program, you are answering one simple question. Do you care about your future generation? If you care about your kids, their grandkids, then you care about sustainability. And a sustainability manager is someone who has the tools to make people understand how they can contribute towards developing a sustainable world. We have both part-time and full-time students. Our curriculum is 30 hours. Instead of thesis, we have a research project course and a seminar course which provides them with the kind of research background they will need to be successful in their job. But at the same time, sustainability is not always everything about environment. It also relates to the business. They will take a sustainable business strategies course. They will take a project management course. Most of these courses are going to be taught by industry people, the people who are doing sustainability on a daily basis as a part of their job. Any organization that has a large number of employees and has a physical infrastructure, they will have to have a sustainability office. If you have the passion to develop and maintain a sustainable world, come to us and we will help you shape your passion into a career which will create an impact.
The Stevens Institute of Technology is proud to present the Hugo New Corporation Sustainability Seminar Series, brought to you by Brown & Codwell, Geocetic Consultants, H2M Architect and Engineers, BEM Systems, and Catalyst Group.
So let's see. All right, so yes, so I've titled my presentation LEED by Example, because we'll be talking about some examples of LEED projects and things that we can learn from LEED. I do have to admit that I did put together the description of this presentation before I actually finished putting the presentation together, so things have moved around a little bit. So the description was kind of purposely vague that you might have seen promoting the event. But we'll do kind of an introduction to LEED and to some other green building rating systems, talk about some myths, cost benefits, and how systems like LEED can influence your design, whether or not a building is seeking certification. I also I titled this An Architect's Perspective. I am an architect. I love being an architect. I worked hard for it, and it's a passion of mine. But one thing at H2M, we participate in the ACE Mentor program. It's a mentorship program for high school students that are interested in architecture, construction, and engineering professions. And inevitably, we always get the question, what's the difference between an engineer and an architect? So I've come to kind of the answer that I give is a lot of times is that, an engineer is a specialist, right? An engineer focuses on less and less topics, like focuses in on a specific topic, but gains a deeper knowledge, right? So an engineer essentially learns more and more and more about less and less and less, which ultimately is, right, learning everything about nothing. Where an architect, on the other hand, is a generalist, right? An architect is almost the opposite, where an architect is learning a little bit about a lot of things, right? So the architect knows less and less and less about more and more and more. So an architect knows nothing about everything. But essentially, these two perspectives are needed in any building project, and really, I would say anything that we're doing. And almost to use nature as a model, where you look at a root system. A root system is, it's vast, but it's also deep, right? So, so some of the things that I'm going to be sharing today are going to come from the architect's perspective and trying to tie a project together, to identify the things that that different disciplines will have synergies when working together. So it's going to be kind of part of my goal here is to identify those things and how the team dynamic is important. We have our individual's expertise, but really working together is key. So I know this is a sustainability master's program, but I think sometimes it's nice to step back to the fundamentals. What is sustainability? This is the kind of, I guess, a widely accepted definition from the Brundtland Commission. right? Meeting the needs of the present without compromising the future to meet their own needs. So we can talk about what needs, right? And we can go to Maslow's hierarchy. Are we looking at our basic physiological needs, self-actualization, something in between there? I think really the point here is that sustainability is necessarily large in scale, right? Sustainability cannot exist within a single building, even though I'm going to be talking about LEED that certifies buildings as being sustainable. We really need to connect scales. We'll talk about that a little bit too. So we are. This is our goal with sustainability, and of course, I'm sure everybody is aware. Knows about the triple bottom line. Economy. We live with economy every day. Ecology, which I think gave really the birth of sustainability, and equity. Something I think that this past year has really kind of brought to the forefront. So I'm going to try to touch on that a little bit too. So what is LEED? So LEED, I'm not going to read this. This is from the USGBC website. But LEED is, it's been around for a little bit over 20 years. First version of LEED came out about the late 90s. It's created by the US Green Building Council. And it's basically a certification system for buildings, right? To see how green or sustainable a building is. And their mission really when they started was to transform the built environment and transform the industry. And I think they've succeeded in that in a lot of ways. There's things 20 years ago we weren't talking about, we didn't know about. Nobody was talking about VOCs 20 years ago. We didn't really know what commissioning was for buildings. Right now you're seeing, probably more Fortune 500 companies have sustainability directors than, they didn't exist 20 years ago. I should also kind of point out that LEED certifies buildings, and there's a professional accreditation for individuals, for professionals. So if you may have noticed, I'm a registered architect in New York. I'm also a LEED AP, a LEED accredited professional. So buildings are certified, people are accredited. That's always a key thing. That's one of the things you find out when you're meeting with people. You ask if you're personally certified, and well, I'm not a building, so I don't get certified, right? So, but LEED started off just focusing on commercial buildings. It has since grown. So now you can gain certification from a single family home to new building, an existing building, and there's even neighborhood development, and there's even recently released a LEED for cities. So kind of that neighborhood development on a larger scale. And with the rating system, there's a bunch of credit categories, which we'll talk about. And there's points available, and depending on how many you get, you would reach a certain level of certification. Here's just kind of a sample of some other green building certification systems that are available. Energy Star, you may be aware of for your appliances at home, but there's Energy Star for buildings as well. It's been around longer than LEED. And you were starting to see kind of different approaches for green building certifications. There's some that focus on attributes, like the well building standard is relatively new, focusing on occupant wellness and health. You may have seen some TV commercials recently. I've noticed a few. Especially with COVID and people looking now for healthy spaces. This is also Fitwell, which is actually created by the CDC, which is along the same lines as well. And then you have certain certifications that focus on project type. So like Envision is for infrastructure projects. And believe it or not, Park Smart, this is a real thing. This is a certification system for parking garages. The Living Building Challenge is probably the high standard when it comes to green building certifications. It was actually born out of LEED, came out of the Cascadia chapter of the USGBC, and is essentially, really striving for true sustainability. Zero energy, zero water. When LEED was started, it started with the intention of being achievable, right? So kind of setting targets that were better than code, ambitious, but not to the point where it would discourage building owners and project teams from trying to achieve them. And as time has passed, LEED has come out with different versions. We're currently up to version 4.1. And each version kind of moves the bar a little further. There's a graph, I don't have it included here, but LEED kind of projects its path from kind of, less bad to neutral to good, right? But I'll touch on the living building a little bit in a couple spots here. Why it matters, well, buildings are ubiquitous, right? We're all sitting in a building now, most likely. I mean, it's a beautiful day out, so maybe some of you are outside. But we're inside basically 90% of the time, if not more. We live, we work, we study, we have fun inside buildings. Buildings are responsible for a large amount of our resource use and our waste generation, solid waste, CO2. So there's a big opportunity here for improving, our lives, not just our buildings. So for a building to be LEED certified, it has to be a permanent building and a permanent location. It has to have occupancy. And one thing that USGBC has implemented probably maybe 10 or so years ago is that building owners are required to share energy and water use data, typically through Energy Star Portfolio Manager. And then there's the credit categories, and there's prerequisites within the credit categories, within most of the categories, things that you have to do regardless of the level of certification. And I just wanted to kind of point out, throughout LEED's existence, there's been a lot of criticism. Some of that I'll bring up, and LEED's responded to some of that. One of the ways that it has done, it's not on this list, but there's a regional priority credits that are available. So one of the early criticisms of LEED was that it was designed as a one size fits all, right? There was no consideration given to the region a project existed within. So water is a good example, right? So water here in the Northeast is a lot different of a resource than it is in the Southwest. The original versions of LEED kind of treated it the same way, regardless of where a project was. So the regional priority credits try to address some of that, where it would award additional points for those credits that are identified as a priority in the region that the project's located. So the integrative process, this is one of the newest credit categories in LEED. And arguably, I would say this is probably the key to sustainability in really any approach, if you're looking at buildings or really anything that you're doing, because this is really how we work, right? And I feel that the path to sustainability isn't necessary. It isn't finding the silver bullet, the new technology or the new expertise. It's really about using the knowledge we have together, right? So it's collaboration, it's building our project teams, identifying the expertise that we needed within our project teams, and then working with the client, the design team, and the build team, right? The construction team, to identify project goals, communicating those goals. And a lot of times we're using energy modeling to kind of hone our design and really optimize our designs. And bringing the project team together, we don't necessarily need modeling, right? So we go back to our indigenous roots and vernacular design, and these structures were not designed using computational modeling, but in a sense they were designed using the integrative process, right? There were project teams, right? There were people that build these that were intimately knowledgeable about their context, about the materials available, about what they were trying to accomplish, right? They're protecting themselves from the elements, maybe from other threats in the area. If you were like on the Bedouin tent on the right, you're nomadic, you're designing something that's easily buildable and something you could take with you. So it's really about, building these project teams. And for us now, it's about bringing in the community groups, bringing in the people that are living in the communities and have that intimate knowledge of where the project location is. It's something that we try to do. Unfortunately, sometimes it doesn't happen, especially with private projects, where a private client is more concerned with schedule than, or more concerned with what the building department says than what the community says, which is unfortunate. But the essential object behind the integrative approach is that we're kind of slowing the pace at the beginning of the project, right? We're taking more time to make decisions earlier on. And this graph kind of outlines that. It's kind of the purple line is our typical project progress, right? This from left to right, we have kind of pre-design through occupancy. And it shows where we're making our decisions, when we're really in that construction documents phase. The design phase is over, but we're still making decisions. If we push that decision process earlier, when the cost of making those decisions is less and the ease of making those decisions is greater, then we're really kind of benefiting the project, right? Even if we're, it seems like we may be putting more effort in the beginning, we're really benefiting the project in, economically and hopefully environmentally as well, and equitably. So the kind of the classic example, I'll share a couple of examples of kind of this process and work. So I think one of the classic case study is the office design project, where the interior designer says, hey, what happens if we paint the ceiling the brightest white that we can find? So with modeling software, we can say, okay, well, now we can reduce our lighting within the space by 1/3, because now the reflectance of the ceiling is, making the lighting that we are including more efficient. And now with less lighting, what does that do to our air conditioning, right? Can we now downsize our air conditioning system because we have less heat gains from the light fixtures? And, without integrative design and having the individual expertise communicated between the team, you're not going to find that the changing of the paint color is going to influence the size of your HVAC equipment. And that's really, kind of the key to this process. And, another example I'll share is a project I worked on where it's really about communications, right? So during the construction of the project, it was a private developer. So we weren't as much involved in the construction phase as the design phase. But during the construction phase, the contractor kind of spoke to the owner and said, hey, I can save you money on your HVAC equipment by, using a different type of equipment. The kind that was designed is, it's overkill for the space. And the owner says, like most owners would say, why wouldn't I want to save money? Sure. So yeah, I want to save the money. Unfortunately, the equipment was designed because the utility, PSEG, this is the Long Island project. Most of the projects I'll be showing you from Long Island, but the utility offered rebates for, high efficiency equipment over standard efficiency, and that rebate would have covered much of the cost premium for the high efficiency equipment. The owner wasn't very happy about that once they found out at the end of the project that the equipment wasn't getting rebated as was expected. And not only that, but they're not going to see the energy savings, throughout the life of that project. That was probably, partially on us because, we didn't communicate with the build team, obviously, and, maybe not well enough with the owner that, these decisions were made, not just because we wanted to have high efficiency equipment, but because of all of the factors involved, the triple bottom line again. So the next credit category is location and transportation. This really has to do with where a project is located, right? So regardless of what you're putting on the property, it's really about the location. And we say that these these credits are inherent to a project location, right? So regardless of what you're doing, you're going to get these credits or not, depending on where you are. It favors, as you can imagine, urban, dense areas, places that have existing infrastructure, right? We're looking for places with different options in transportation infrastructure, density, amenities that would be beneficial to building users. And, it's not typical for a project that we get to, work with an owner in selecting a location. But if that opportunity comes, this is something to consider. And you think of real estate, right? So real estate, it's location, 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 right? And there's a reason for that. Some areas are are in demand more because of the amenities that they offer. If you're a business and you're looking for space that might be closer to your labor force, your customer base, might provide more equitable access to your building, whether it's for employees or customers or visitors or whatever you're doing. And this is a project at H2M. It's actually a LEED ND, a LEED neighborhood development project. One thing I did want to just kind of touch on is on these slides here, when I introduce the credit categories, they have the BD&C, which is the building design and construction. That's for kind of new construction, major renovation. And the O&M is operations and maintenance. So there's a separate kind of LEED certification for existing buildings. But this is the Ronkonkoma hub. I don't know if anybody is familiar with Long Island. Ronkonkoma is about in the middle of the island. It's one of the main transportation lines of the Long Island Railroad. It's the station you would go to if you were going to the MacArthur Airport. I've commuted from this station. I've commuted from the station for a couple of years at a previous employer, but it's largely suburban residential. But this new transit-oriented development, which is partially complete, still I think under construction, has a dense residential, retail, commercial spaces, even a hotel, and it's kind of this illustration of identifying the location, the existing infrastructure, and it provides a clear transportation right into New York City, which is a lot of employment opportunities, and people don't necessarily want to have a car and still live on Long Island, which is difficult in the suburbs. This is an example of where you could do it. But there's a lot of green infrastructure, green roofs, bioretention, things like that. I will talk more about rainwater management with the site credits. But one of the credits that was criticized probably from the origin of LEED was that you can get a credit for a bike rack, right? That was the statement. It was, I can get a credit for a bike rack, or I can get a credit for putting solar panels on my roof. And it more or less correct. There was more to it than just a bike rack. But you had to provide a changing room, showers for people that would use bikes. LEED, to address that criticism, projects to gain that credit now have to be connected to a bicycle network. So you can't just say that, oh, we're providing, bike storage and changing facilities. You have to show that, you have to show that your building would actually be used with, by people on bikes. So that's also kind of, it kind of touches on our scale, changing in scale and addressing larger scales, right? I mentioned earlier, sustainability is necessarily large scale. So when you start to identify infrastructure, like bicycle infrastructure, alternative transportation infrastructure, that's beyond your building, beyond your project, then you're starting to connect with your community. And we'll talk about that shortly. So now sustainable sites, this is where you're developing your site, right? You're assessing your site, where you're developing, identifying the natural flows, sun, wind, water, surface water, subsurface water, and really kind of identifying where the site, the prime development site, is in harmony with the natural flows. You're also going to try to provide open space, right? So I think, the existing context is relevant for that. The reduction of light pollution and the heat island effect. And this is where LEED starts to address that scale jumping as well, which is how the Living Building Challenge puts it. Living Building Challenge has kind of a whole level of their certification where you can connect scales, where you're going from building to region. So with for the sustainable sites credit category and LEED, for the existing building, the operation and maintenance, there's this community sharing of facilities credits. That would be like, for instance, a school, say a school building has an auditorium that they use on occasion, but what would be able to connect with maybe a local theater group that could use the auditorium when, after school hours or on the weekends or when the school isn't using the facility. So you start to address community scale with the use of your building. So it's not just isolated within your property boundary. But so this is a project that H2M worked on. It's not a LEED project. It was just a parking lot for the Planting Fields Arboretum. It's a nice parking lot, right, as parking lots go, and then I think addresses a lot of the things that LEED brings up. You see a nice amount of plants here, right? You're seeing landscaping more than you'd see in your typical parking lot, providing a lot of shade, right? The whole right side of the photo is a shaded parking lot. The light fixtures are designed to be dark sky compliant, right? Reducing light trespass beyond the property and into the sky, which is beneficial to us and nature. And there's it's all pervious pavement here. So instead of having dry wells scattered throughout the site, where the rain falls, it can seep into the ground, kind of more matching the natural hydrology of the site. One thing with pervious pavement is that you have to just make sure that the facilities managers, the clients, are aware there is additional maintenance that's required, and just the ongoing maintenance, and even like during snow season when you're clearing snow, not to use sand, right? Because essentially pervious pavement is the same pavement but without the fines, without the sand. So you're not going to want to use sand during snow removal. And if you do, there's some other maintenance you have to do. You might have to vacuum out the site to remove those fines, to make sure that is still functioning as it's designed. So this is, I mentioned regional priority credits earlier, and this is a regional priority credit for Long Island because stormwater runoff and the damage it can do to our surface water bodies. This is a map of the Long Island Sound. It's a little outdated, but I'm sure things haven't changed a whole lot. It shows the dissolved oxygen in the water, and you can see where there's more development, you're getting lower dissolved oxygen rates, right? So what's happening is that as water is running off from our impervious surfaces where it's not seeping into the ground, it's taking with it all the pollutants and the fertilizers and things like that, and it's washing into the waters. It causes algae blooms, and that's then suffocating the rest of the marine life, whereby reducing that dissolved oxygen. Water efficiency. This is deals with interior and exterior water use. Water, as I mentioned earlier, is another kind of a regional issue, right? So in the Northeast, we have an abundance of water typically. Other areas of the country aren't as lucky. But one thing to keep in mind is that water water use isn't just about the water, right? It's also about energy. One of the largest energy users here on Long Island is the Suffolk County Water Authority. All right, so water requires a tremendous amount of energy to treat and to pump. So water is not just a water resource issue, it's also energy, carbon emissions issue. For indoor water use, we're seeing low flow water fixtures are available even at Home Depot, right? You can buy a dual flush toilet and low flow fixtures. And for exterior water use, we're really looking at irrigation design or landscape design that can reduce the need for irrigation. A couple things to keep in mind, right? Things that we've learned is that some municipalities require irrigation for commercial buildings. So it's working with them, using more efficient. This is an image of a drip irrigation system. So instead of spraying water in the air or misting it, you're providing it directly to the roots where it's needed, a lot more efficient. If you can use a gray water system or a rainwater capture system, they're not as widely accepted on Long Island, but we're kind of working, and we'll kind of talk about that in a moment. And we are learning some things too, as we're seeing the increased use of low flow fixtures that require some additional effort and some due diligence on the design team. Right, so there's a couple things specifically more for existing buildings. If we're looking at existing building for, say, getting rid of waste, through toilets and urinals and laboratories and things like that, a lot of times the systems were designed, they're gravity fed, so size of piping and pitching might be designed for a larger water flow. So with our lower water flows, we might want to just investigate that. And also there's been concern, or it's been brought up, of water sitting in pipes longer because the flow rates aren't using the water as quickly. So the concern with waterborne contaminants being able to develop further with, as the chlorine kind of wears off and evaporates. So this is a project at the Suffolk County Environmental Center. It's a project I worked at prior to H2M. It was an old Grosvenor Atterbury mansion, a beautiful building that the county had taken possession of and turned it into the environmental center. This was the greenhouse that was on the site, and we were looking to turn it into a living machine. I don't know if you guys have studied living machines. Developed by Dr. John Todd, and basically using plants and algae and fish to break down waste, right? So the objective was that the waste from the building would come to the greenhouse, and that would kind of be the demonstration project. And it would kind of be the sewage system for the building. The Suffolk Health Department, which manages that, there's no sewers in this area. They wanted us to demonstrate the nitrogen levels basically to drinking level standards coming out of the system, which we thought was unreasonable, but we couldn't meet those standards. So what we ended up doing is we still provided this system, but then ultimately the effluent from this would then feed into a standard septic system, which was accepted by the health department. This is another project. This was for the New York City DEP. There was a yard where they stored their garbage trucks, and they were using a tremendous amount of water because at the end of each day, they would hose down all the trucks, using potable water, right? So this is, I don't remember the exact size, probably like a, 25,000 gallon rainwater cistern, which the idea was now to use rainwater to hose down the trucks rather than potable water. And this was an exciting project for H2M. Again, not a LEED project, but really embracing water efficiency and water reuse. It's actually the first water reuse project in New York State. it was the Riverhead water treatment plant located right next to a golf course. Golf courses, as you can imagine, use a tremendous amount of water, especially during the summer. So this collaboration between the two, right? The purple pipes is this reused, non-potable water. So the water is, treated to a certain level, not to drinking level standards, but before it would be otherwise released into the nearby waterway, it now being used to water the golf course in the summertime, and it's somewhere in the range of 350,000 gallons a day during the high season. Not the most efficient sprinklers, right? But we do what we can. So energy and atmosphere, I don't know if I mentioned, but LEED stands for Leadership in Energy and Environmental Design, right? Energy is right in the name. So LEED has to address energy. This was another early criticism of LEED. The earlier versions of LEED didn't necessarily require an increased energy performance, right? There was credits you could achieve, but there was no requirement. Now there's a minimum 5% energy improvement over baseline. LEED uses ASHRAE 90.1 as the baseline that energy performance is compared to. LEED is used everywhere. Some states like New York, New Jersey have energy codes that are adopted based on the model energy codes. There are areas of the country that have adopted earlier versions of that code. So the ASHRAE is set as the baseline. California has more ambitious energy codes, so meeting energy code is going to meet the baseline for LEED, for energy performance. So I love this image. This was from the New York Times, and it when you talk about energy use and we talk about energy use intensity, we can look at either source energy or site energy. Source energy is that kind of chunk at the bottom, right? That's all the energy that's produced at the power plant, right? Regardless of the whether it's coal, nuclear, renewable energy, that's all that we're using. And then the top, the top that's the energy that really gets to our buildings, that gets to be used. That's only a third, right? So the grid in itself is only 33% efficient, right? All that the rest of that is lost. So this is kind of a pitch for smaller grids, for microgrids, distributed energy, even demand response, where buildings can adjust their loads based on peak load, right? Because if that utility can kind of level out their load and know what it's going to be, we're going to have a little bit less of that loss. And it's interesting too, if you think about source and site energy use, you could probably, you could make the argument if you wanted to that like something like a ground source heat pump, which is usually touted as a sustainable energy source. If you're using basically electricity to run that system, if you're using that electricity from the grid, that's only a 33% efficient system. Whereas using, instead of burning the gas at the power plant, if you burn the gas in a gas-fired unit on your site, it could be 90+% efficient. That you could argue that a ground source heat pump is less environmentally friendly than the gas, right? In that sense, but we need to really. There's a lot of efforts to green the grid. I think we should advocate for that to continue, and but there's still issues with the power grid that we need to consider in developments. So when approaching a project, so these are just some screenshots for some of the software that we have at H2M. Kind of one of the first things to do is to identify your load profile for your building. Where is your energy being used? Because when you want to identify efficiency measures, you want to target the low-hanging fruit. You want to know what's using the most energy, so where you can save the most. So you can look up, Energy Star has resources where you could look up building types and have a typical energy use profile. Some utility companies will have that available for more regional data, and software can kind of hone that too, so you can really identify based on the form and the location of your building. And then you can identify that energy use intensity, how much energy the building is using per square foot, and compare that with targets, right? This software compares it to the 2030 challenge. But you can have your own goal set for the project. This is the same software, so you can model your building. You can do simple daylight analysis, which is what's shown on the right. Show the kind of the light and the dark spaces, and then there's a bunch of these response curves that you can generate, and you basically pick the parameters that you want to use. This is looking at the wall R value, the wall insulation value. And it's based on energy cost, right? So on the bottom, the horizontal shows our R value, how insulative it is. And then the vertical is the energy cost. And you could see we get to a point where if you go from R15 to R20, you're gaining, just for R5, you're gaining a lot of savings there. But then if you look at the R25 to 30, it's minimal, right? And even then you start to go where you start actually spending more money on energy. So it helps to optimize your building envelope, right? And this is before we're designing systems, so that we can design those systems efficiently and right size them for the space that's going to be that we're going to provide for our clients. Commissioning. So commissioning is, I would say, one of the things that LEED has brought to the forefront, right? Before LEED, I was just starting architecture school when LEED came out. So I can't speak from experience that people weren't talking about commissioning buildings before LEED, but commissioning is now a code requirement in the energy code for certain equipment sizes. LEED has expanded their commissioning to now there's an option to do envelope commissioning. We're actually, making sure, so just to back up for a minute, just to kind of, since I don't know what everybody knows already, what you've touched base, in your studies so far, but what is commissioning? So commissioning is basically a evaluation of construction to ensure that building systems have been constructed as per the design documents, the design requirements and the owner's requirements, right? So there'll be functional testing and inspections, things of that sort. And it's mostly for energy systems, but again, their commissioning is being expanded to even building envelope, where they'll do like a blower door test. I don't know if anybody's had that done in their home, where they'll test the leakage rates of your wall assemblies and can make corrections. I could share a story for a project that I worked on that was a LEED project. So it was therefore being commissioned. A lot of owners hesitate at LEED sometimes because of commissioning. Commissioning is a requirement for LEED projects, and building owners will say, well, I don't want to spend the money for commissioning. I would argue that commissioning pays for itself. And in the case of Long Island, the utility offers rebates for LEED projects directly for commissioning. They'll pay 75% of the commissioning costs up to $100,000, which is, it's, most projects aren't going to, total commissioning is not going to be $100,000. So this project, part of the commissioning testing was duct blower tests. So they, kind of put a fan at the duct and they blow air through it to see how well sealed the ductwork is. And this one particular test came back and the duct was leaking at a tremendous rate. We weren't sure why. So, we had the contractor remove a part of the ceiling, and it turned out that the mechanical contractor had a apparently run out of ductwork and decided to complete the part that was missing with plywood, not sealed at all, right? Not designed to what ductwork would be designed to. So the deficiency was corrected, the test performed until it met the design requirements. But things like that is, we're now designing and building, and owners are purchasing high efficiency equipment, and that efficiency has to follow through in the construction phase. And also commissioning and involves training of personnel, so that, especially with more advanced equipment, where facilities are learning how to use it correctly. Right, so this is a great quote I love from Michael Bloomberg, right? In God we trust, everyone else bring data, right? So it kind of references the energy modeling and the commissioning, right? I still have a couple more. I see that we're about a quarter to. I'm gonna try to speed through these a little bit more. So with energy, we're looking at embodied carbon. We're looking at, operational carbon, right? So that's the carbon emissions that come from operating our buildings, where when we look at our materials, what our buildings are made of, we're looking at our embodied carbon, right? So as our buildings grow and as our energy efficiency increases, embodied carbon becomes a bigger portion of what we need to focus on. So this credit category looks at that. It looks at environmentally preferable materials, and also construction waste. So construction waste is another thing that LEED has kind of brought to the attention of contractors, right? This is not an unfamiliar sight now at job sites, where contractors are sorting their waste on site so that we can divert the waste from the landfill. A lot of contractors have expressed that they've seen this as a cash positive change for them. Right now they're really able to sell back this valuable, what we call waste, right? William McDonough talks about waste, and in nature there is no waste. Waste becomes a food for another process. So we're trying to emulate that. With the kind of more recent changes with how China's not really taking as much of our recycling, where much of it goes, haven't really seen an impact yet for construction waste, but we'll see how things go. This year hasn't been the normal year for construction. So here's that kind of embodied and operational carbon graph, right? So you see that kind of yellow orange bars represent the embodied carbon, right? That's all the carbon that's needed to provide the materials, right? Our material extraction, or our manufacturing, or fabricating, or transportation to the site. And the operational carbon, the bluish, is our buildings operating, how we're running equipment, HVAC, computers, all of our stuff inside the building. And we could see for this 30-year period, we kind of hit that point where the operational carbon surpasses the total embodied carbon at that. This is from 2020 to 2050. Right, this graph is provided by Architecture 2030. And Architecture 2030's goal is that by 2030, our buildings will be operationally carbon neutral, or carbon negative, right? So that means that the operational carbon really in this graph is gonna drop down when we get to that 2030 mark. And you could see at that point, embodied carbon now is 3/4 of our total carbon footprint. So to look at this, we need to look at our materials, right? We're seeing more advances in timber frame construction, with heavy timber construction, even for skyscrapers, for high rises, and looking at material reuse, regional materials, right? So that's something that's always been big with LEED, promoting regional material sourcing. Also material labels, right? FSC is a Forest Stewardship Council for responsible forestry. We're seeing more material transparency, where companies are listing the ingredients, right? The declare label here. This was created by the Living Building Institute, which is the Living Future Institute, sorry, which is the creators of the Living Building Challenge. So this lists all of the ingredients within a product, and it highlights those that are either materials of concern or what it calls red list, which are those that are known to be harmful to humans or nature. And there's a requirement now that in living buildings that all the materials must be red list free. It's somewhat difficult to find some of these, but it's becoming easier and easier every day. More material manufacturers are making materials available and making the information about these available. The environmental product declarations are a kind of like a life cycle assessment. They're typically cradle to gate, which means from material extraction to basically install into a building. It doesn't necessarily deal with maintenance or disposal after. So we're still got room to grow and advance there. Indoor environmental quality, this is the last credit category. So we'll have some time for questions. And we're looking at, this is again with COVID, this has become more of a important topic, I think, for people. And things like well building are addressing these directly, but it's also about the materials that we're using, right? So in California, there's Prop 65, and it basically says that any buildings that contain materials that are harmful have to be labeled. So even in Disneyland, right, here's the sign here in Disneyland that states that there's chemicals known to cause cancer and birth defects. There was a study by, I think it was Perkins and Will, probably 10 years ago or so, where they were looking at, can we design, an office space with available materials at the time that wouldn't require this label? And they found at that time that there wasn't, right? There wasn't enough commercially available finished materials to not put toxic materials in our spaces. This is changing, right? We're seeing, so the environmental product declarations also has now there's health product declarations, which are really more focused on environmental health and human health and toxic materials in the materials that we're using in our buildings. So we're seeing more of these labels and these third-party verifications that guide us to more healthy building materials. And indoor environmental quality is more than that, right? They say that the two biggest complaints in a building is it's too hot and it's too cold, right? So obviously thermal comfort is something we're concerned about, but also lighting, daylighting, access to nature, just a window with a view provides tremendous benefit. There's now lighting that mimics daylight to kind of address our circadian rhythms and how we've evolved to respond to nature, and our hundreds of thousands of years of existence on Earth, we've only lived the past 100 or so not outside and connected to nature. So we have to kind of reconnect and retune ourselves. And this is another H2M project. This is Outdoor Learning Center. It's kind of a funny name for that because it's all indoors, but just some of the elements that we're trying to include here that address indoor environmental quality and wellness. Daylighting, operable windows. It's amazing how much sometimes it's a struggle to get operable windows, especially with some mechanical engineers. It's like, oh, it's easier to just have windows that don't open, but operable windows, shading devices, right, so that we're not getting glare, so that we can maintain access to that daylight, and even the picture on the bottom left shows a stairway, which it's open, it's got windows, it's an attractive stair. So with the promotion of wellness is giving people the the desire to use the stair over the elevator because it's a nice place to be. And in this particular building, you know, we used a limited material palette, right? The picture on the bottom right, you know, open ceilings, polished concrete floors, kind of, you know, the less we're bringing in, the less potential toxic materials we're bringing in. And it's really, you know, about creating spaces that we want to be in, right? That are fulfilling to ourselves, and functional, but are beautiful. I think that's important. I love this quote from JFK, but there's another one that, you know, I'll kind of paraphrase from Buckminster Fuller. You know, he said like something along the lines that, you know, I don't always strive to make something beautiful, but if at the end of my design, if it's not beautiful, it's not the right design, right? So beauty is inherent in good design, essentially, is what he's saying. So that's what I have. Hopefully, I didn't go too long, and everybody got something out of that.